Imagine you are driving in Bangalore and you see traffic ahead, or you see traffic in Google Map. So you will try to take a different route, right? So that's the concept of conditional probability. Conditional probability helps you adjust your choices based on the other situations. Let's take one more example. Suppose one doctor has to decide whether a patient has a particular disease or not. How he or she will decide? Based on some other conditions like few medical test results, few symptoms the person is having, right? So here also the probability of a person having a disease changes based on this other situations or condition. So this is conditional probability, and it's used in various application in various fields, right? Starting from healthcare like this medical diagnosis, in tech, in various machine learning and artificial intelligence applications, and weather forecasting, sports analysis, financial market analysis, gaming, and whatnot. So in this video, we'll try to discuss the basics of conditional probability. So let's get started.
Conditional probability is the probability of an event occurring given that another event has already occurred. The conditional probability of an event A under the condition of another event B is known as the probability of A given B, and it's usually written as P probability of A bar B. Now we'll see one small example. Let's say one sample space we have 1, 2, 3, 4, 5 and 6, right? And one event we have 1, 3 and 5. One more event we have 3, 4 and 5. Now we want to calculate probability of A given B, right? So if you want to think it logically, what does this mean? Probability of A given B means B has already occurred, so the outcome is from this 3, 4 and 5. So given that the outcome is from 3, 4, 5, what is the probability that the outcome is from A? So 3 and 5 is present in A as well as in B. So given B has already occurred, there is 2/3 chance that A has occurred, right? So probability of A given B will be here 2 out of 3. So there is a formula to compute the conditional probability. So that is probability of A given B is probability of A intersection B divided by probability of B. Let's try to compute probability of A given B using this formula also. So what is probability of A intersection B? There are two elements in common in A and B. That is 3 and 5, right? So probability of A intersection B will be 2 out of 6. What is probability of B? There are 3 elements in B, so probability of B will be 3 out of 6. So if you see here, this one and this one are same. So if we just get rid of this 6 and 6, the number of sample space size, so we will just get the same outcome. So basically we are doing the same thing. So we can try to use this formula to compute conditional probability, and if you want to think it logically, we can just think of like how much of A is in B. Now we'll see one example. So there are 500 students in a class. 150 students have enrolled in algebra course and 80 students have enrolled in a chemistry course. There are 30 students who are taking both algebra and chemistry. If a student is chosen at random, what is the probability that the student is taking chemistry given that the student is also taking algebra, and what is the probability that the student is taking algebra given that the student is also taking chemistry. Let's first try to draw a Venn diagram. So we have 500 students in total. Let's A is the students taking algebra and C is students taking chemistry. So there are 150 students have taken algebra, 80 students have taken chemistry, right? And 30 students have taken both, right? Algebra and chemistry both. So let's calculate probability of A, that is 150 out of 500, right? That is 3 out of 10. Probability of C is probability of students taking chemistry, that is 80 out of 500, that is 4 out of 25. Now also we have 30 students, they have taken algebra and chemistry both, right? So probability of A intersection C, that is 30 out of 500, so that is 3 out of 50, right? So we have to calculate first probability of student is first we have to calculate student is taking chemistry given that the student is also taking algebra. So first we have to calculate probability of C given A, right? Probability of student taking chemistry given the student is also taking algebra. So if we just use the formula, it is probability of A intersection C divided by probability of A, right? So it's basically 3 out of 50 divided by 3 out of 10, right? So if this is 1 out of 5. Next we have to calculate probability of A given C, probability of students taking algebra given that the student is also taking chemistry. So that is also using the formula probability of A intersection C divided by probability of C, right? So that is 3 out of 50 divided by 4 out of 25. So this is 3 out of 8, right? So that's how we compute conditional probability.